It's Tanzu Tuesdays with your host, Robert Burley.
Back my papers. I feel like I should have like newspapers. That's so news official. Hello, everyone. Welcome to Tanzu Tuesday. I don't know. I always have to do something ridiculous because my wife, now my coworker, excuse me, always makes fun of me. So I have to do some sort of ridiculous at the top. Welcome, everyone. Thank you so much for joining us. I don't know, for all of our regulars, if you tried to join us last week, we obviously took the week off to support the Black Lives Movement that was happening. It's still happening, and we still are very behind it and encouraging.
I still hear music.
I don't hear music. Did your fiance turn off his music?
No, like I still see starting soon and hearing music there. Weird.
Oh, are we not on the?
Uh-oh.
Let's see. No, I see you on the screen. I'm there.
Oof.
There it is. Cora says all good. B. McLean says all good. All right, we're all good.
Right.
Anyway,
It hates me.
like I was saying, we're all very much still conscious of what's happening and the needed changes that have been going unchanged for a very long time. So keep educating yourselves, everyone. Keep making this world a better place and keep teaching these children love, love, love. All right, I have said it. And we shall move on. And I want to thank Spencer, who was last week's guest, and you were so wonderful to switch the week after. And next week, Dr. David Sire was able to push back. And it was lucky for my scheduling because I didn't have anybody on the 23rd. So we were able to not have to reschedule too many people. So here we are. Welcome, Cora. Thank you, Brian. All of our friends out there that are watching. We're so happy that you're joining us. And Paul, Tiffany, hi. How are you? Good to see you.
Hi. How's it going?
Hi.
Fine. Yes. Thank you. Were you typing "welcome, folks" as I was?
I was. You know me. I am the worst of single tasking people. I cannot type and talk at the same time.
It is. It is.
I can, but I type
waffling.
what I'm thinking.
Right. Yeah, it's called waffling, where you fill up the one container and then it gets filled, and then you move on to the next one. That's what I learned in my marriage counseling with my friend's dad, who decided to, or who was like lovely enough to marry my wife and I. He said, "Women are spaghetti and men are waffles." And basically gave us this whole thing where women can multitask, and like noodles are intertwined, and they can be in one room and know what's happening in the other, and know what's going on with, like they just can be doing all things at once. And guys are like, I only know what's in front of me until I'm done, and then I can go over it. So it's very true. And so my wife will yell at me, "You're waffling," which is what I'm doing right now. Because I want to talk to Spencer. Spencer, welcome, sir. Hello.
Hey, hello.
Look at that goatee of glory. It is. Now, when we do the show live, like we did last year, this goatee was not there. No, really a beard. It was a clean-shaven man.
Paul can testify on the beard during last year's Spring Summit tour in Asia and Australia.
Right. Yes. So, I was not privy to that one.
Yeah, it comes and goes, typically with the weather.
I will say it is definitely looking a little bit grayer than last time I saw it.
Oh,
but then
boy.
I think mine is as well. And I think that's probably more the unkempt nature of our current self-care than anything else. Speaking of which, Bob,
Yeah.
I see your quarantine
It's
haircut is coming back, and it doesn't look.
Yeah, actually, I need a trim up on the sides.
Yeah, it's looking much better.
Yeah. Thank you. Yes. Yeah, my mom actually was like, "Don't do that again." And I was like, "Well, it wasn't like it was done on purpose, Mom. It was an experiment, and what else am I doing? I'm not going anywhere." So anyway, it was just funny. I like the mom input. Don't do that again. So yeah, my hat days are behind me. I feel fine with this current incantation and moving forward.
We have a cosmetologist in the house, right?
Oh.
My 18-year-old daughter is this close to graduating with her license. She just, once they open back up, she just needs to get some hours. But we have like a salon chair and everything in the house. So
That's incredible. Well done. Yeah, I wouldn't trust my 4.5-year, almost 5-year-old.
Yeah,
with,
I
the
have
scissors.
I have 2 adult children.
Right. Yes.
In air quotes, yes.
Well, so let's talk a little bit more about you. You have 2 adult children.
And 2 little ones.
And so you have 4 kids. Wow. Look at you.
I have 4
Okay.
daughters.
Wow.
Yep.
The ladies.
Yeah.
Lots of spaghetti.
Lots of, yes, exactly. It's pasta night every night.
That's right. Yeah. I currently I'm in Southeast Michigan, not far from Ann Arbor.
Cool.
What else? My 6-year anniversary with the spring team is next week.
Wow. Congratulations. Yeah, that's really good.
Yeah, so it's been fun and a good ride. So happy to be here.
And as you mentioned, you're, and I did as well, you're a veteran of the Spring One Tour. Speaking of which, let me get to a little bit of housekeeping.
House cleaning.
We do have our Spring One cleaning and keeping.
I did some house cleaning yesterday. I was proud.
Oh, good. Wonderful. Yes, we have spring1.io to go and register to attend September 2nd and 3rd's all free conference, all things spring. Will you be speaking at that, Spencer?
I submitted a few talks, so
hopefully. That's right, because May 20th, I think, was when the submission was ended, so they're probably still going through all that.
Yeah, one was RSocket themed, which we'll be talking about today. So.
We've got pretty high standards for that conference, so I'm not sure Spencer's got that caliber of who we're looking for.
Yeah, I mean, Tanzu Tuesday.
Oh, okay, automatic reject of Paul's talk for being a jerk.
5 years.
Maybe another 5 and you can get lucky. Who knows? And also the Spring One Tour we were talking about, that's what made me think of this, is we pushed it back a week. So it's June 29th and 30th now. And Cora Iberclyde and Andreas Evers will be talking about CI/CD experience with Kubernetes Edition. So again, go to spring1tour.io, click on the June 29th, 30th to register. If for some reason you don't have that ability to do that, but you still want to watch it and you remember, you can watch it on our Make Jar Not War channel of Twitch, twitch.tv/MakeJarNotWar. You can watch only. We do have Q&A sections in that, which is great. And so that's why registering is much more important, so that you can be a part of the conversation. We also, again, have our developer portal up, tanzu.vmware.com/developer. Check out that page. Our new little developer/TV is our new website on that, so you can see the fancy new design. And then last but not least, Cloud Foundry Summit is happening. It's another virtual conference, of course. I think that's pretty much can be blanket stated for the rest of 2020. But June 24th and 25th, go to cloudfoundry.org and you can register and see all the amazing talks that are happening around Cloud Foundry, the open source project geared towards platforming as a service. I think I did.
That was a lot.
Yeah,
you did
that's
good.
a lot. But thank you for sticking in there, everybody. Shall we get it on with the show? Shall we have Spencer for hire do his thing? Oh, Mama Bear is there. Hi, Tasha. Good to see you, Tasha. All right, Spencer, you ready?
Sure. Let's share my screen.
Share that screen. And again, we might you're a veteran to this show, so we might jump in and just say hi to you a couple times.
That's great.
Hi.
Now I just realized when we were getting your avatar drawn, clearly they did it from a photo where you didn't have a beard. So the little avatar in the corner doesn't entirely look like you right now, but that's all right.
Yeah. So everybody get a little like a Sharpie at home and just mark a little beard goatee on your computer screen, and that's totally fine.
So I have a couple of little statue things up there from our first trip to Beijing. One of them has one doesn't.
Oh,
anyway.
One does have the beard.
Yeah.
So you can kind of like rotate them, like which one's
Proof
on.
it's the same person.
Yeah.
All right, Spencer, without further ado, please wow us and have a great show.
Awesome. So speaking of Cora, she did contribute some of these slides too, so that's why her name is up here. So today we're going to.
And real quick, everybody, Cora's back on the team for another 3 months. So that hashtag keep Cora an advocate, it worked. So good work, everybody. We're so happy, Cora. So happy.
Yes, that's awesome. She is awesome. So we're going to talk a little bit about reactive architectures with RSocket and Spring. Let me get the legalese out of the way first, just because this is in development. You can screenshot it if you want to read the whole thing. So we'll talk a little bit about reactive architectures. If I'm not mistaken, I think I watched Josh do his reactive talk on this very channel not too long ago. So that'll be a little bit of a review. We'll talk about RSocket, what it's about, and then we'll talk about the work I've been doing on this RSocket routing broker and hopefully get into some demos. So reactive, what in the world does that mean? So starting with reactive streams is kind of like where I like to start. A bunch of companies got together to define the this specification just as a way to provide a common language that systems can interact with, right? There's if you go to reactivestreams.org, you can read more about it, but really the interesting thing here is the non-blocking nature of the stream processing and also back pressure. So there are 4 interfaces that are described in reactive streams: publisher, subscriber, subscription, and processor. And those made their way into Java 9. So this still not ubiquitous as far as the JVM goes. So the reactive streams implementation is still around and will still likely be until, I don't know, we'll see what happens when Java 17 and the next long-term support for Java comes around. On the Spring VMware side, Project Reactor is our implementation of reactive streams. If you recall, we won't talk a whole lot about these, but we may see them in some demo code a little bit. But as far as streams go, a flux is 0 or to n things, and a mono is 0 or 1 things as far as that goes. And there's also integration with Java 8 streams and some of the other building blocks there. But the reactive streams interfaces are nice when you want to, for example, I've dealt with RxJava from the Netflix side for a long time with regards to Hystrix, for example, where that's what they use internally. And so when you want to integrate a WebFlux application from Spring, like Spring Cloud Gateway or something, you have to do some bridging there, and that's what those types are useful for. So, but there are roadblocks, right? When we're talking about reactive streams, that's for a single JVM. So what about data access? Well, for a while, I think Josh has a tweet where he lists a whole bunch of things, but you know, databases like Mongo or Cassandra or Redis that control their clients directly, they already have reactive non-blocking clients. The relational database side was a kind of a black hole there. We have taken some steps to fill that with R2DBC, which is just one of the greatest names for a project, by the way. Any Star Wars fans out there? Speaking of whistling, was that you, Tiffany? Did you make those? Anyway,
you know I can't whistle. Don't do that to me.
So very interesting. There was a asynchronous database access that Oracle was doing, but now they're implementing an R2DBC driver for Oracle. So seems like that has kind of got momentum there. So, but still this is all kind of a single process, but what about networking, right? So what happens, how do you do back pressure across the network, right? And so that's where, and what really is back pressure? So it's the ability for either side of a conversation to say, you know, I've got too much, or this is all I can handle at this point. And so being able to do that across a network is a pretty amazing thing. So that's one of the things that we need still across the network. It doesn't matter, it can be synchronous or asynchronous. You know, this is showing some event loops and making calls across the network, but the key differentiator really is the back pressure. And so that's where RSocket comes in. So the story of RSocket is that some folks that worked at Netflix, these are folks that created some of the original Netflix OSS, like Hystrix and RxJava and Ribbon and things like that in the early days of AWS that they were using. And as the distributed systems ecosystem grew, there are various ways to solve some of these problems, right? You know, theirs were Java libraries, right? But there are other ways to do it, and there are a couple different approaches. One that a lot of people have taken is kind of push it down to the platform, right? So this is where we get things like a service mesh that can handle circuit breaking and load balancing and things. So the designers of RSocket went, well, maybe we even need to go to a different layer, and we go to the network protocol layer. What if the network protocol handled some of these issues for us? And that's where RSocket came into being. So folks from a company called Netify, a lot of them were former Netflix. They're folks at Facebook and now Alibaba and VMware and on the Spring team specifically are behind RSocket. It's a very well thought out protocol, very well documented. It's, you know, go look at the specification at RSocket.io. It's very easy to understand and read.
I believe, Spencer, you have a joke, an RSocket-based joke.
What is a pirate's favorite protocol, Paul?
R.
Here we go. We got Mark Heckler to do that live on stage in Beijing, I believe. That was the highlight for us. So some properties of RSocket. It is bidirectional and multiplexed. So you open one connection to where you need to go, and then all communication happens over the single connection. It is message-based, which is a bit different than some of the other RPC mechanisms and HTTP and other things that you're used to seeing. So it has a bit of a unique model. It is binary, right? So it's very efficient, but it doesn't care what your payload is. And it's all based on this concept of reactive streams back pressure. So there are 4 interaction models that the protocol defines. You'll also see these show up in, for example, the Java RSocket interface, right? Request and response. This is fairly standard, right? This is what happens when you do a HTTP GET or POST or something like that. Request response. Fire and forget is closer to what some are used to with messaging platforms, right? I just send a message. I don't care about a response. A request stream. So for example, if we take the analog in HTTP, this might be like server sent events, right? We make a request and then we get this stream of data coming back. And request channel is streams in both directions. And so that's the unique, that's a building block. You can do basically anything with that one once you have it. It can be built, it can be run on multiple transports. So kind of by default, it's TCP, but if you want to have a browser be a client, WebSocket works. And then we can add other implementations as we need them, or as requirements are different, and they take the protocol allows for delegating to the underlying transport for certain pieces of that. So it's a well thought out, extensible protocol. So just to get an idea of some of the differences between RSocket and something that you're used to, here's a little bit of a comparison with HTTP. So RSocket has a single connection, and sorry, I went out of full screen there. HTTP has a new connection per request. RSocket has multiplexed messages you can pipeline. HTTP is slowly gaining some of these things. Again, this idea of back pressure that can be communicated. Basically, on an HTTP request, you can get a status code back, but what does that really mean unless there's more information, passed back from the client? One interesting thing about RSocket is once a connection is made, the client and server roles kind of go away, and you have requester and responder, because either side can make requests and either side can respond. So for example, if you had a client in a browser, some server on the other side of the network or on the internet can make a request to the browser because and it can respond. Something else that's interesting is canceling and resuming streams. So if you know that work doesn't need to be done anymore, you can cancel it, and you know that it will stop sending data. But if you made an HTTP request and tried to cancel it, it may have gotten already across and you don't know. So that's very interesting property that RSocket has. So let's get into routing and how this RSocket routing project helps with the RSocket protocol. So first, we're going to get kind of a crazy diagram that shows some of the components of the RSocket ecosystem, as well as Spring, and how these things kind of merge. So at the bottom, we have the reactive streams that we've talked about. We've talked about RSocket. So this is all built, these projects that I'll be showing are built on the RSocket Java implementation. So RSocket Java depends on our project reactor that we talked about. And so does Spring Framework and Spring Boot. But there are other RSocket implementations, right? And more happening as we speak. I think Python is in the works. I think there may be a Ruby one in the works. I'm not sure. I can't remember. Anyway, but it doesn't really matter because it's just literally an implementation of the specification. So as we move up to these parts, there is an RSocket routing specification, and this we'll talk about some of the things that defines. And then the broker and the routing client are built on top of that specification. So if that's a big ball of mud, hopefully we'll make it a little more clear as we go along. So some vocabulary, if you're not familiar, some of these are if you're familiar with messaging systems, you'll already be familiar with them. But a broker, this forwards RSocket requests to the right destinations. Routing, so this is how we create and share these routing tables. Some other interesting things here, what we call an address is forwarding a request to a routing destination or routable destination. A tag is a key value pair, and these are the things that we use to look up routes in the routing table, metadata, other key value pairs. So we'll use some of these things as we go along. So when I started this project, it was originally under Spring Cloud Gateway, but things have changed, and these projects now are under being built in partnership with VMware and Netify and other community contributors under the Reactive Foundation. They're in the RSocket Routing GitHub org. I'll give you that link towards the end. So these are still in the works, but things are getting closer. The RSocket routing and forwarding specification, I call it an extension specification because it's an extension of the RSocket protocol. But there will still likely be changes there. And this is all done with the Java implementation, but there's no reason there, and there likely will be implementations of the routing client in JavaScript and Go and .NET, etc. All right, so let's talk a little bit about the client. So this what this does is it gathers all the information that you need to register with a broker and to send requests, right? It's meant to be fairly lightweight and to kind of get out of your way. The Spring, so you could use the RSocket Java, the RSocket routing client library without Spring, but we're obviously talking about Spring. So what does the Spring bits provide? It provides auto configuration to automatically connect to brokers, configuration properties so that when you're doing your Spring Boot application, it's simple to configure. We'll also talk a bit about this RSocket requester. This is a Spring Framework class that gets configured to automatically add some bits so that you don't have to. The broker, so let's talk about the broker. So let's get a picture. We'll be talking for this next little bit about the broker here and what that looks like. Again, this kind of shows you can have multiple clients in whatever language, it doesn't really matter. But the brokers accept connections from clients and also from other brokers. And when a client connects, we start to build this routing table. I bring up that it's indexed using roaring bitmaps. If you like reading white papers, go to roaringbitmap.org. It was my first time actually implementing reverse indexes, and it was quite enjoyable. So if you like that kind of stuff, go have fun. Anyway, it's very efficient. Bitmaps can be expensive memory-wise, and so roaring bitmap is a mechanism to cut down on that memory while still providing speed. So once the routing brokers have to do some communication with each other before they can start forwarding connections. And like I said before, clients can be in any language that they just need the right bits of metadata. And like I said, I expect we'll have clients for these other languages written, so it'll be easy to use. Some of one of the things that the RSocket specification routing specification defines are a couple of, we call them frames in the RSocket world. We have a route setup frame and a route add frame. So route setup is what a client sends to the broker when it connects to a broker, and then the other brokers will forward that information via a route add frame. So the decision was made to implement the broker using Spring, since it's not as dependent on the client, right? You might have clients that aren't Spring, and that's fine. But internally, we use support from Spring Framework for message mapping in RSocket Requester, and so it's very easy to update and maintain the broker, and even really to extend it if you wanted to do that. We can listen on any supported transport. I'll be demoing TCP, but the idea would be that you might have a node or two that listen on, or a couple of nodes that listen on WebSocket, for example. So you can have external clients that go through WebSockets, and everyone else through TCP, for example. Security, the support for RSocket in Spring Security, and so the broker can be secured by using Spring Security. So the typical things that you would expect. There's a great talk from Springwell last year by Rasen Stoyanchev and Rob Winch and Brian Closell about that talks about Spring Security and the kinds of things you can do in securing basically a Spring Boot app that uses RSocket. And so we'll just take advantage of that. So we get the broader team providing security for the RSocket broker. We'll be requiring micrometer, which again is part of Spring Boot, for metrics at different levels. So just general metrics overall of the broker, metrics per connection, and metrics that are specific to different kinds of requests. So the idea is that you could be able to get a picture from whatever system you're using to gather metrics. You could be able to get a fairly decent picture of what your broker cluster is doing. So a broker cluster wouldn't have to be very large. The idea would be to keep it small, right? Once you are talking about high availability, typically I'm showing 3 here, right? I can handle a 33% failure or just one node before things start to break down. But so typically 5 would be a number you might see. But so now we're going to talk about, what happens when clients connect to a broker and what it looks like and what kind of things happen. So when you make a connection to a client, you send this route setup frame, and it has some information in it that's interesting. The route ID, so this is one of the extensions of the RSocket protocol, the routing metadata, and so that's what that bit is. So people know, for example, I'll show you examples, but for example, you might see this as anyway, I'll show an example here in a little bit. The service name, so this is the user service or the shopping cart service or whatever that is, and then you can start to send other tags that might make things interesting, like region or instance name or version, right? You might be able to have multiple versions of a service up, for example, and then when you make a request, you can include these tags. And so I want to make a request to version 1 of this service or version 2 of that service, and the broker will take care of that. So this is what this looks like. So this big red circle right here, when you create a client, you can set it up, if you're on whatever cloud you happen to be running on, you can block all incoming connections, right? The client has to make a connection to the broker. Brokers don't connect to the client. So secure by default, right? The only way into the client is through the existing connection to the broker. So that reduces any attack vectors. When you do make a connection to the broker, like I said, you say I'm service A. Each client that connects has to have a unique route ID for the routing table. By default, we generate some random route IDs, but you can also specify it, and I'll be doing that in the demos, but this is my instance name. I'm service A #1, but the broker can choose to reject the connection, right? So if you aren't presenting the right credentials in your RSocket request, then the broker can deny that request. So again, this is where Spring Security would come in, and it's set up to do that already. So one of the interesting properties is that with this information that we provide, service name and ID and other tags, other metadata that might be besides instance name, as we're gathering this information, our broker is becoming somewhat of a service registry, right? Since you connect to the broker, the broker knows about everything that's connected to it. And so one of the goals of this broker is that in an application where all the communication is done over RSocket, you could use this as your single service registry. So once you're connected, so now we have our persistent connections into our broker. How do we make a call? So I talked about those 4 different interaction models that RSocket has. So say I want to make a request response call. What do I have to add? So I have to say what service I want to communicate with, right? And then again, we can add other tags. So maybe I want to communicate with the user service that's in my region, or a very particular instance, or a version. And then we also want the routing metadata. So this would be like the path of the HTTP request that you're making, right? So if that's add user or something like that, or delete user or get user, right? So that's what that routing metadata is. And there are different, now that we have a broker, we can start to do different things that look more like other message brokers, right? So by default, routing is unicast, right? We send the request to a single instance, but we can also multicast. So I could say, send this request to all the instances of service name, or all the instances of the user service with a particular version. And then we can also do sharding. So sharding is, if you're familiar with databases that do that, or with Kafka and that have sharding set up, you can also create some subset of services that you route to based on a shard key. And that looks like this. So you say, here I am, this Java client, I want to connect to the user service, for example, and I want to call the echo route. So we make that request, we send that metadata. One thing you'll notice is that the client doesn't need a client-side load balancer. There's no sidecar, there's no circuit breaker. Some of these things are handled by the protocol because of back pressure and other features of the RSocket protocol. And the broker is taking care of load balancing for you. So that is a feature of the load balancer, or of the broker, excuse me. It does the load balancing for you. So the idea here is that to get a system that is distributed and has the properties you need to overcome outages and problems that happen in your network, that the infrastructure required to do this is smaller, right? Some small number of brokers that would be able to handle a large amount of communication, but do it efficiently without running extra infrastructure. So when we make this connection, so what happens if service A, there's nothing over here yet? So one of the properties of Reactive Streams is back pressure, right? So in this case, we can actually accept the request, but apply 100% back pressure from the broker. So it says, I got your request. There's no one available to reply. And as you'll see in a demo that I'll do in a little bit, that back pressure is applied, and the Project Reactor has methods that allow you to deal with that back pressure, and you'll see what you can do for that. So I don't know if any, if I was in a room, I'm sure I'd get a lot of hands, but how many people have, we need to bring up staging or test or something. We have to bring everything up in the right order, otherwise it all falls apart. And how do you typically deal with those ordering problems? Well, speaking from what we've done in Spring Cloud, for example, for config server, right? Config server is something you want up because you want to get your configuration for your services. But if it's not up, what do? Well, the client, we have retry, right? With an exponential backoff after each retry, so that, and then a timeout eventually. If it doesn't come up within a certain period of time, it will just fail to start up, right? So this is typically what happens. And so this avoids some of these things. So other things that can happen, the service needs to do some warm up before it's ready to start accepting connections. So it can be up, but not accepting connections. And so these ordering things can, a system like this can help avoid those ordering problems. And once they're up, the responses just start flowing. The other bit that can happen here is that we have a chance for the broker to enforce security, right? So can, this particular client make a request to service A or to route echo, right? So you could potentially enforce these at the broker level, and so that you can segment your systems however you need them to be segmented. Metrics are also collected here at a request level, so we can start to see things like, how many requests are being made to service a echo, right? So we can start to see those kinds of metrics. So recap some things you won't see that you don't need. Ingress permissions, right? I don't think I've ever really heard of a system where no connections in, right? Only connections out, and that could be the default. You might not need a separate service discovery system. Circuit breakers can be handled by the RSocket protocol. You don't need a client-side load balancer because the broker is handling that for you, right? There's no sidecar, right? This doesn't need a service mesh to work. Would it work with one? Yes, but it doesn't have to have one. And then you avoid these startup ordering problems in special cases for warm-up. And in certain cases where you don't need persistent messages, right? You might not even need a message broker. We see certain systems in the commercial Spring Cloud world that are moving from requiring a message broker like RabbitMQ to move to RSocket, for example, so they don't need that expensive, system up and running, and it's just a boot app. I say this when I talk about Spring Cloud Gateway, but these brokers are just boot apps, right? So they're the same as the rest of your infrastructure if that's what you're doing. So let's get into some demo then. My demo is fairly simple. If you go watch Josh Long's very, very early on RSocket Spring Tips video, he creates a simple ping pong demo. I won't do just the direct connection, but that's usually when you see demos with RSocket, they are direct connect, right? From One's acting as a client, one's acting as a server. You make a connection. One has to be listening. And you tend to the demos kind of tend to gloss over the fact that you can only if you want to connect to someone else, you have to make another connection, right? So in the microservices world, right, you'd have a connection to every single microservice that you needed to connect to, which doesn't look very good. So here we go. We can initiate messages. Anyone can request. Great. This is a request channel, so we can send multiple pings. They can send multiple pongs, and it all works great. So, but what about Pong's friends, right? We can't do this, so we need something in between, and that's where the broker comes in. So then the broker knows where all these things live, and they don't have to. Ping doesn't have to deal with that. All right, so let's see if we can't show this stuff working. See if we can make something wiggle. All right, so this is my sample project. Again, you'll get a link to the GitHub project at the end. We are using Spring Boot 2.3, and I have 3 different projects, 3 different modules in the project: Ping, Pong, and the broker. So let's start with the broker. I would hope eventually these things will show up on Josh's second favorite place on the internet, right? Start.spring.io. For now, you'll have to add these dependencies. So here, Spring Boot Starter RSocket and the RSocket Routing broker. We do a little configuration. Like I said, we're providing IDs by hand. You don't have to do this, but it's useful in debugging so you know which one you're looking at. This defines what port we're going to be listening on TCP. And then the cluster port is the brokers maintain separate connection amongst themselves. So they're kind of cliquish, they have their own connections. Anyway, and I'll also be running another instance of the broker a little bit later, and that's what this part is for. So let's go ahead and start our broker. Make our text bigger here. So we get some logging. We started broker with ID 11. The broker is listening on TCP port 8002, and the cluster is listening on TCP. So this is with Netty, right? So this is if you're doing an RSocket server right now, we are using Netty. Okay, so broker's up and running. Let's look at Ping, and I'll give you a walkthrough of what these projects look like to begin with as we get into the demos, so you can see kind of what some of these concepts I've been talking about as I've gone along. So again, Spring Boot Starter. Am I still there?
Yeah, you're still here.
Okay. I just had something blink in my headset that I was like, So we have then the routing client. I can show you what the configuration looks like. Again, a route ID, and then here we start to have some of the metadata that we've talked about. So we need a service name, and then I've created this instance name of ping1. And this is what I'm going to connect the broker to the broker. In the future, if you're running on Kubernetes, for example, we could have a Kubernetes lookup, so you wouldn't have to know even the host of the brokers. You could just say, connect to the broker service, for example, on Kubernetes, or if you had Eureka for something else, or if you're on Cloud Foundry, or whatever the case may be, rather than a hard-coded list here. The ping service does not receive any requests. It only makes requests. So I have a few dependencies that I have auto-configured. This class, the Spring Routing client, and then some properties. And this may change in the future, but right now we have an application event that provides us with the RSocket requester. So our application starts on an application event, and then by default, this is what, using that requester, we're making a request to Pong RC, which this is the routing metadata that we talked about. Now, by default, the Spring Routing client will look for a key in this address map. You can see Pong RC, and it will send these tags automatically to match against the service that you're looking for in the routing table. Now, if we wanted to do that by hand instead of by properties, we could certainly do that. There is a metadata method on the RSocket requester, and then this Spring Routing client has some convenience classes to create this address metadata automatically, but programmatically. So if you wanted to do it that way, this would do the same thing as this declarative way of doing it. Okay. We'll go ahead and comment that out though. And we call retrieve flux. And so let's back up just a little bit. We're sending a flux every 1 second. And we're going to retrieve a flux. So that translates into request channel, right? Flux coming in, flux coming out. And then we're just going to log them as we go. We'll get into this one here in a little bit when we see what happens. But every second we're going to send a pong, right? Or a ping. So let's go ahead and start our ping application. So we can see here, we started ping, little debugging information here. On this side, we can see some logging that we accepted the route setup for ping, and then we indexed it, for example. Now, if I scroll down, you'll see this line of pressure here. Since there's no Pong to connect to, the broker has created this kind of virtual service to communicate and hold as a placeholder. And some of the methods available in Project Reactor allow you to do things like, in my case, I'm just dropping and printing something, but you could buffer them, you could error out. There are other different strategies that you could have here. So we're just hanging out waiting, okay? So let's start our Pong application. And so now you can see that on the ping side, we've started to receive Pongs, and Pong immediately started to accept pings. Okay. So fancy demo. We have ping pong happening, okay? ahead and stop for a second. Now this is a very, very simple demo, so and not very useful because you're typically not going to have one broker, right? So you're going to have multiple brokers associated with it. So let's go ahead and start that as well. So we'll start our same broker application. If I come back here, we're going to start, it's the same same Java file, just with a different Spring profile. We're going to start broker 2 with a different ID with its own TCP port and cluster port. And then we're going to connect to our original broker. So let's go ahead and start broker 2. I'm not doing much different. I'm basically just Spring profiles active. That's the only parameter I'm adding, which then activates this part of the application.yaml. So go ahead and start that. So if we go back to broker 1, we can see I have some debug logging on here as well, but we received a connection and we stored this other broker. And then on the broker on the other side, the first broker 1 said, hey, I'm here. And broker 2 went, oh, I've already got a connection to you. Since I'm already connected, there's no need to make 2 connections going across the other way. But they've both done a handshake so now that they can route to any service that is connected to them on either side. So let's go ahead and start our same ping application. So this is the same one connecting to broker 1. Again, we're going to get the same thing. Let's see what happened in broker 1. So we got our ping application connected, but then in broker 2, we have this line here that says, oh, hey, I'm broker 1, ping 1 just connected to me, so I'm telling you about ping 1. So now broker 2 knows about ping 1, which is connected to broker 1. Okay. Again, it's still doing the same thing, this on back pressure bit here. So now if I connect Pong to broker 2 instead of broker 1, we see that it immediately starts receiving pings basically through the cluster. So the farthest hop you would ever make is 1 extra node in the broker cluster, but in reality those connections are already there, right? So that's typically this is why we typically have connection pools, right? Because the overhead of creating the connection is the thing that is slow. And so in these cases, that isn't the case. So it's an extra hop. And they modeled this after, TCP or IP, right? Those protocols expect there to be something in between the requester and the responder. So that's how this broker, just with the right metadata, it will just forward on the requests to the right places. And so let's see, maybe I'll make another ping application connect to broker 1 and see if that just all blows up. No, it didn't, right? Okay, so we started receiving. So now we have 2 pings connecting to the 1 Pong, right? So we can start to see that these are dynamic. And by having the configuration for your applications be in configuration, you could potentially change the your architecture without changing the code very much, right? So say that you used to have a single service that answered queries for users, but all of a sudden you have two and they're segmented. Well, you could change this to say, hey, this needs to be a multicast request. And so get an answer from all of the user services and return me each one, because each one manages some different subset, right? If that were sharded or something like that. So very, very interesting things that you can start to see. The other interesting bits that we are working on is load balancing. For right now, this is just using round robin load balancing in the broker. But if you think of, we've kind of called it unfair load balancing, right? I'm going to treat clients that are responding quicker, I'm going to give them more, right? So I'm going to favor them, hence the unfair bit. So you can imagine that if requests in your local data center are faster than a remote data center, for example, requests will come locally. But say there's a failure that happens in your local domain, your local data center, but the other ones are still responding, they're just slower, right? So it just slows down a little bit. It doesn't totally start to fail and back up. So those are some of the other things we are working on. All right, so I think that is end of demo time. So roadmap. Again, this will be going under the Reactive Foundation. Links on the next slide to projects and things. So even though it's not under a Spring org, we are committed to it and we are heavily invested in building it. We have continuous integration up and running. So we have snapshots being published to bin tray. So you can start to use this without having to do a build yourself. We'll hopefully get that RSocket routing specification completed so that we can have a 1.0, which just happened with RSocket Java. Just had a 1.0 release not too long ago. We're working on documentation, some clustering enhancements, like when I start up another, for example, if I started up another node right now, a broker node, I would have to tell it where the other two are, but I should just be able to give it a seed node and then the cluster would communicate all the available nodes to the new one. We need to do tracing integration. So this is systems like Zipkin that provide, a way to do, to see what parts of your system are slow and very specific. We need to do some fault tolerance improvements, and then also the last bit of routing, the sharded routing, needs to be implemented. Shouldn't be too hard. It's basically a specialization of broadcasts, or the multicast routing. So should be fairly easy to do. Yes, so that's it. Here are links to the current projects under the RSocket routing GitHub org. This is the sample that I used that has been updated to use the latest things. I was fixing bugs this morning. So things weren't working. Demo-driven development. And this is me on Twitter. Notice the B, right? If you drop the B, you'll get a musician, not me. But hey, maybe that might be more interesting. So, yes, there we have it.
Woohoo! You done did it. Look at you, professional. We asked for 60 to 90. You gave us 60 to 90. Winner, winner, chicken dinner. Spencer Gibb for the win. Thank you very much, sir. I hope everyone got their RSocket tightened just a little bit more. There it is. Very nice. Tightened up just a little bit because their knowledge has increased +1. And you're going to be doing a Spring One tour in August, right? The virtual Spring One tour, Spencer?
Yes, I am working with one of your colleagues, one of our colleagues, I guess. He's my colleague too, but specifically from your team.
I was gonna say that sounds like a parent thing. Do you know what your
Yeah,
son did?
yeah,
We're like one
right.
of your colleagues.
I have all daughters, so they're all her daughters, right?
Right,
Anyway,
right.
yeah, with Nate Shutta on, we'll be talking about microservices with Spring, and yeah, should
Wonderful.
be good times. That is one of the talks actually that I submitted to Spring One, so it'll be a bit of a preview
Ooh.
of that talk.
So if it does get accepted, then we'll make sure people are taking notes in August because there will be a test in September. That's what you're saying. Cool.
Yeah.
Well, yes, we do love us some Nate. He is a fan favorite around here.
Yeah.
And particularly in my house, everybody goes, Nate? They know him, which is cute. Well, great. Well, so yes, everyone, please tune in to the spring1.io to register for that event that hopefully, Spencer, I mean, I'm really hoping that you get your talk accepted, man. I'm going to see what I can do.
I don't know. One of my teammates is on one of the committees, so
Ooh.
we'll see.
Right.
We'll see.
It's all right.
Well,
Bob.
cool.
Bob
Yes.
knows people. We'll get you.
Yeah. To include a certain doctor.
Fairness, everybody. Fairness.
Going to be on next week. Little Dr. David Sire will be joining us next week from across the pond, as they like to say, jolly old England.
Yep.
Also a Spring One tour regular, very fun guy.
The other co-founder of Spring Cloud, right? So it was me and Dave for a few years on our lonesomes, working on it. So
well, that's weird.
He
He
also
told
likes
me
to
he
use...
was the founder of Spring Cloud.
Awkward.
I hope you got some aloe vera in that household of yours for that sick burn you just got.
We like Dave. We still keep him around. We still invite him to meetings.
There it is. Yeah, he's a good one. So yeah, we'll be talking with him next week. I don't think actually it's up on our website yet what he's going to be talking about.
I believe it
performance,
is, or it's waiting to be merged up. I think it's in a queue.
Is he doing?
He's doing spring experiments. More often than not, Spring moves forward by reacting to demand, but sometimes it also tries to move first into a new area, anticipating demand in the community. So we'll be talking.
Cool.
Yeah, absolutely. Yeah, he's we're excited to have him, and then Brian Lyles will be after him in a couple weeks, trying to get his information so we can put it up on the website. So if you're watching, everybody, send me your info so I can put it on the website. I got you, Dr. David Sire. I got yours. So anyway, I had to reload my page, so I don't know if like Sweet Killer 9 was watching. I saw McLean, of course, and Cora, and I don't know if Java Grunt or Deshaun Carter was watching, but if any of our normals or regulars were watching.
I haven't seen either of them.
Yeah, well, and of course, I saw Tasha joined on early. So thank you all again for joining us, Spencer. We thank you. This was awesome, and we really appreciate your time and energies.
Thanks for having me.
And Paul, Tiffany, I also appreciate you.
Well, we appreciate you.
I appreciate you too. I was saying we, and then I was like, I shouldn't be speaking for Paul. So.
Don't ever.
You can use the royal we. It's okay.
Well, yeah,
Bob does the royal we all the time.
Hey-oh, in the royal toilet. It's the throne. There it is.
It is the throne, yes.
Yep, I had to make the leap, and then I got it.
Yeah.
She could have her cat on her lap or something like that, and she'd be like, we, you know. Do you have a cat?
I'm so allergic. You wouldn't want to see me with a cat on my lap.
Never mind then. And you couldn't whistle for help either, because you'd be...
Get out, jerk.
Anyway, well...
I guess your goal is to teach me how to whistle then.
The challenge accepted.
We could do a stream of just that.
Yep.
Oh,
An hour and a half of Bob teaching Tiffany how to whistle.
Put your lips together and blow. Was that like Humphrey Bogart said that or something like that? Was that a famous old line? But anyway, yes, we will. That will be a non-sponsored Tanzu Tuesday. That'll be a Whistling Wednesday. Nailed it. For the diplomat. Whistling Wednesday. Cool whip. All right, my friends. Everyone out there, please take care of yourselves. Take care of each other. This is incredibly important times that we're living in, and I really hope that we're all opening our hearts and our minds to making this a better place all over the world. And Spencer, thank you again for your time. Paul, Tiffany, until next week with Dr. David Sire. Take care, everybody.
Bye-bye.